All right, welcome to section 3.5 in our book, where we are going to be talking about the derivatives of trig functions. And we're going to start by looking at sine, the most basic, or one of the two most basic trig functions. And what I want to do is I want to just take a quick look at the graph and see if we can come up with a conjecture for what the derivative of sine might be. So I have graphed both sine and the derivative of sine on the same set of axes. I've made the window approximately 2 pi wide so that we can see one full cycle of sine. And here's what we have for the graph. The blue obviously is sine of x. The red is the derivative of sine. And if I look carefully at this, it sure does look like the derivative of sine is in fact cosine. So we're going to look at this a little bit more. But for now, what we'll say is that my conjecture is that the derivative of sine is cosine. All right. So we're going to need a couple limits for this particular proof. And the first one is what happens if we take sine of x divided by x, or in this case, sine of h divided by h as h goes to 0. Now, we've actually seen this one before. We know that it's equal to 1, and I've gone ahead and put it into the calculator. So if we take a look at the table, we can see obviously it's undefined at 0, but we can see it getting closer and closer and closer to positive 1 as we get closer and closer to 0. And we can also see this on the graph. So when we look at the graph of this, and I've already zoomed in on this, you can see that it sure looks like it just approaches 1. So we're going to say that the limit of sine of h over h as h goes to 0 is 1. And the second limit that we need is going to be this one, which is the limit as h goes to 0 of cosine of h minus 1 all divided by h. And again, I've graphed that, so let me pull that one up. And looking at the graph, zoomed in quite a bit, sure does look like 0. And then let's go ahead and take a look at the table. And when we look at the table, oops, why did that come up? When we look at the table, that also sure looks like that's approaching 0. We can see that we're down to 0.005 on the left and negative 0.005 on the right. And we could zoom in if we wanted more, but I think we can confidently say that in fact this limit is equal to 0. We're going to use both of these limits in the proof. So very quickly on to the proof. The derivative with respect to x of sine of x equals the limit as h goes to 0 of sine of x plus h minus sine of x. I'm using definition of derivative here, all divided by h. So what do we know about sine of a plus b? Well, this is equal to sine of a cosine of b minus, plus sine of b cosine of a, your angle sum identity. So we can write this as the limit as h goes to 0 of sine of x cosine h plus sine h cosine x minus sine x all divided by h. We're going to do a little fiddling here. We're going to take the two terms that have signs of x, and we're going to put them together. So this gives us the limit as h goes to 0 of, to 0 of, and factoring out the sine, I get sine of x times cosine h minus 1 plus sine of h cosine of x all over h. And then I can do a little more fiddling. I'm going to take out the sine of x, because it doesn't have an h in it, multiplied by the limit as h goes to 0 of cosine h minus 1 over h. We've seen that before. Plus, and then we'll take out the cosine because it doesn't have an h in it. And again, these just go back to our limit rules. What can we do with limits? And we're left with sine of h over h. Seen that before. Well, since sine of x does not depend on h, the limit as h goes to 0, sine of x is just sine of x. We already determined that this thing right here was equal to 0. Cosine of x, since it's not dependent on h, is just going to be cosine of x as h goes to 0. And we already determined that this thing right here was equal to 1. Well, sine of x times 0 is 0. Cosine of x times 1 is cosine of x. And what we have in fact proved now is that the derivative of sine is equal to cosine. Okay, and we'll be back in video 2 with more derivatives.